Hello, everybody. So, welcome to Alpha Coder Academy's education sessions. Today is session number 1, and today's topic is Java parameter passing by value or by reference, meaning how do we pass parameters in Java from one method to another method, and it goes by value or by reference. All right. So I hope that everybody knows here what is a parameter passing from one method when we send some parameters to another method. And the question is, and it's a very important, though very common question in interviews, when the interviewer asks you, what does Java support? Is a parameter passing by value or by reference? And most people have probably read it or heard that, okay, Java sends parameter or pass parameters by value. But what actually is by value means? Does the reference goes or does the actual value goes or both? Let's look at that. All right, so here is my here's my Eclipse, and then I have a class here that this is a primitive passing that I have a method. Okay, my class name is primitive pass, and I have a method which is static in this case, but non-static work as well. Same way, the method name is modify. It doesn't return anything, and it receives two integer parameters, x1 and y1, and it reassigns values 5 and 10 respectively to x1 and y1. And here is my main method. I created two integer variables, x and y, initialize them with values 1 and 2. And then I call the method modify. I pass the two parameters x and y, which in this case are primitive methods, right? So when this method gets called, the x and y values comes into x1 and y1. And then I'm changing the values of x1 and y1 here, x1 to 5, y1 to 10, whereas I had initialized initially 1 and 2. And this modify method, when it comes here, x1 and y1, they holds value 1 and 2 respectively. And then I reinitialize them, or I give them a new values 5 and 10. Now the question is whether x and y values, they change x and y variables, they change the values to 5 and 10, or they remain they keep the original value 1 and 2. So that's where I'm printing x is equal to this and y is equal to this, right? I hope this is a very simple program, nothing magic here. And then before I try to run this program, think in your mind, what should be the answer? What will it print? X equal to 5 or x equal to 1? Y equal to 10 or y equal to 2? What will it print? Okay, I hope that you have your answer in your mind, and let's run this. If I execute this program, I get this x1 and y2, whereas I had changed the values x1 to 5 and y1 to 10, whereas this x and y were sent to this x1 and y1. I changed the value of x1 and y1 here, but it did not change the original value held in the original variables. Why? What is happening inside? Let's look at it. Okay, so before we go look at what is happening inside, let's have a quick look at the JVM memory structure, how the JVM handles the memory allocated. So the orange box that you see, is the total memory available or given by OS to the Java process, right? Whatever, maybe 64 KB to whatever, some GBs, 1 GB, 2, whatever number of amount of memory is given by OS to the Java process. And then what Java does is it further subdivides the whole allocated memory into different pieces, and it calls that, some chunk of memory is called method area, some chunk is called heap area and stack area, PC registers, native method block, etc., etc. What are these different areas? That is not the point for today's discussion. For today's discussion, the only two areas are important for you to know. One is the stack area and one is heap area. I hope that everybody knows what is stack area and what is heap area, right? And now, by the way, for those who doesn't know what is stack, um, the heap is the area where Java creates new objects. So whenever you say object A is equal to new object, anything created with new goes to heap. And the variable created like this, the object A goes to stack, right? So one stack area is given to every thread. So each thread has its own stack area. Okay, it's just a quick introduction about both. Now we look at what is happening when we run this parameter passing of the primitive values. When we pass the parameters, the primitive type parameters, what happens here? Like this. So the thread which is executing the main method has two variables, has created two variables, x and y, and it has initialized the initial value 1 and 2. And then we have the heap area also, because we are not creating any object with new keyword, nothing goes to heap. Everything remains in the stack area. And of course, in this case, you notice that because we are creating the primitive type variables, they are created directly in stack without any reference to the heap area. Okay, so that's why the main method, whatever the memory allocated in the stack to this thread, while executing the main method, it creates two variables and that goes to stack area, initialized with value 1 and 2. This is when executing the line number 11 and 12. Now, if you notice what is line number 11 and 12, are these two. So I'm just creating the two variables here. Okay. Now, what happens next? When it calls the method at line number 5 and it calls the method modify, what happens here? When it calls the method at line number 14, it comes here at this, and then at this point in time, x1 and y1, they receive the value of x and y. So what is happening behind the scene is this. So the stack now contains the variables given to the method modify on top of the main the variables of the main method. And now we have two variables in this, x1 and y1. The initialized value with the given values 1 and 2. So you see, it's the primitive type actually sending their original value to the parameter. X1 and y1 now have the value 1 and 2. Okay. Now what happens? We are here, x1 and y1 are initialized with value. And now we are saying that x1 is 5 and y1 is 10. What happens after the line number 6 and 7? Let's look at this. So when the line number 6 and 7 executes, the value x1 and the value y1 in the stack area changes to 5 and 10. Easy, right? And then the method is done. It finished. The control comes back to this line 17. And then when we try to print, what is the value of x and y? Let's look at that. At this point in time itself, you can see that the x and y value of the main method variables are not changed. What has changed are the values of x1 and y1, which are the variables of the method modify only. That means the original variables of the main method have not changed. And that is why when it comes back to the line number 17 and 18, which happens to be the print, the values are still 1 and 2 only, right? And that's why we are getting the value 1 here, and x1 is 1 and y1 is 2. Easy? So in this case, you can see the parameters are passed as value. Now, we saw this is the case for primitives. Now, what are the primitive types? There are 8 primitive type data types. Java has 8 primitive data types, right? Integer is one of them, but this is applicable for other 7 types also. Float, double, int, short, long, etc., etc. So the primitive type values are passed, primitive type variables are passed by value, not by reference. I hope that this is clear. And now we go to the second. What happens if we pass an object instead of the primitive values? We pass an instance of a custom class, right? And the custom class means, so here is my complex pass, my class name, and I have created a static inner class, just the name as my class, and it has one integer num, and here's the constructor. It receives a value and it assigns to this. So my class variable is initialized here. Now here is a method again, the modify. It's a static method, but it doesn't really matter here. It receives 2 objects of my class, A1 and B1. And A1.num plus plus, so whatever the value this variable holds for object A1 is increased here. And B1, I assign a new variable, I assign a new instance, and then also I increase the num variable here. This is the main method. I create an object A, new my class, value given 1. Another object B of my class, value given 1 again, right? So in this case, I created 2 instances of my class. And here I'm calling the modify. When it goes, A and B goes here, what happens? The A1 receives the value given to A, and B1 receives the value given to B. So what was the original value of A1? A, in this case 1, and B also 1. So I hope that you understand at this point in time, A1 receives A, value 1, B1 receives B, value 1 again. And now I'm incrementing the A1 value and B1 new instance, and again incrementing B1 value. And then after this modify method is done, I'm printing both values, A.num and B.num. Now think about your answer and tell me what will be printed here. Whether, because we are incrementing A num plus plus and B num plus plus, whether it will print 1 1 both sides, whether it will print 2 and 2 both sides because both the instances are being incremented, or 1, 2 or 2, 1, whatever. Think about this scenario. What is your answer? And then here I'm running, uh, going to run this program. There is execution, and I see, you see this 2 is the value of A and 1 is the value of B. What is happening? I'm incrementing A1 and I'm also incrementing B1. Why A1 was able to increase and but A was able to increase the value and B was not able to increase the value. B value is still the same, the original 1, but A value has been changed. But why? Why A value also been changed? When we say that the Java parameter passed by value only, so 1 should have gone here in both the side. A is 1 value, B is 1 value. 1 should have gone there. And whatever happens in this modify method should not affect A and B original variables. And why A dot num is 2 in this case? Let's look at that. Okay. So now the class instances, when we pass the parameters of the class instances, in this case, my class, what happens here? At the line number 21, 22, look at this. When I'm creating the instances, 2 variables here, A and B, this is what happens in the main method. A and B are created. Huh? And let's say, because we are using this new object, new keyword, new my class, some value, new my class, some value. New will use a heap, and the object actually gets created in the heap area, whereas the variable goes into stack area. So what happens here now? The stack has 2 variables now, A and B, which holds the reference to the memory location of the corresponding object created via the new object. क्या हो रहा है यहाँ पर मैं जो ऑब्जेक्ट हमने न्यू कीवर्ड के साथ क्रिएट किया वो जाता है हीप मेमोरी और जो उसका वेरिएबल है वो जाता है स्टैक में। तो स्टैक में 2 वेरिएबल बन गए ए और बी और ऑब्जेक्ट कहाँ क्रिएट हुए हीप में। तो एनी मेमोरी इज रेफरेंस्ड बाय इट्स लोकेशन, राइट। हर मेमोरी लोकेशन का, हर मेमोरी बाइट का एक लोकेशन होता है। फॉर एग्जांपल इन दिस केस हमने समझा कि एक जो ए वेरिएबल बन रहा है उसका लोकेशन 200 है और बी वेरिएबल जो बन रहा है उसका लोकेशन हीप में 100 है। I mean, it may not be 100 or 200, not 100 or 200, it may be actually alphanumeric, the location, the memory address, we call it memory address, okay? But for simplicity, just for you to understand that the 100 and 200 is actually a reference to the byte which is holding the value of the object here, right? The actual value heap में है 1 and 1 in both the cases, but variable क्या hold कर रहा है उसका memory address, right? So variable जो A और B है that is holding 100 and 200, the actual memory location of the object created in the heap, and the value is being held in the heap, which is 1 and 1. Clear? Now what happens? At this point in time, we call the modify method, which comes here. So A1 and B1 gets created, and let's see what happens here. So A1 and B1, अभी तक हमने देखा the variables in the stack are being passed to the new method as value only. So in this case, what is the value? Value is 100 and 200. just assume that this is the value of the memory location, but it will be alphanumeric, some A, 0, 10, whatever, blah, blah, blah. Okay. So in this case, when the method modify is being called, the actual value is being transmitted. In this case, 100 and 200. So what happens here? A1 and B1 actually points to the same object being created in heap earlier, right? So same A and B, ये जो दो वेरिएबल हैं, ये दो ऑब्जेक्ट्स को जहाँ पे हीप में पॉइंट करते हैं, वहीं अब A1 और B1 भी पॉइंट करता है, राइट? अब क्या होता है? When this a1.num is being executed, तो अब क्या होता है यहाँ पर में? हम लोग उस रेफरेंस को यूज करके उसकी वैल्यू बढ़ा रहे हैं. तो यहाँ पे क्या हुआ? a1 जिसको पॉइंट कर रहा है उस ऑब्जेक्ट की हमने वैल्यू 2 कर दी. a1 200 को पॉइंट कर रहा है, तो उसका num हो गया. तो यहाँ पर इसका वैल्यू हो गया 2, राइट? यू सी दैट हमने a1 की वैल्यू चेंज नहीं कर रहे हैं हम लोग. a1 जो ऑब्जेक्ट को पॉइंट कर रहा है उसकी वैल्यू चेंज किया हमने, a1.num तो हमने हीप में वैल्यू चेंज की. ओके, एंड नाउ व्हाट हैपेंस हियर? व्हाट हैपेंस हियर? b1 इज इक्वल टू न्यू माई क्लास 1. हम एक नया ऑब्जेक्ट बना रहे हैं, एंड देन दैट रेफरेंस or that address is going into b1. कैसे रिप्रेजेंट करें? Like this. You see the red line here. We have created a new object, and that we have given the value 1, which is now being pointed by b1. And then after executing line number 17, which is incrementing the value of b1 num, which is actually the new object created. So ये जो ऑब्जेक्ट बना था initially was value 1, and now it has been increased to 2, and you see the b1 value has been increased to, or has been changed actually, to 300, assuming this object memory location is 300 here. Okay, so in this case what is happening is, because it was earlier pointing to the same object, now when we gave it a new object, the JVM created a new variable or new object in heap and stored its reference into b1. So b1 now points to the new object, not the old object, the 100 one. And then we have increased the value of b1, which is increasing the value here, not the original object. So what happens when the modify method is done? These two values will be popped out of the stack, and when the control comes here, again, you are printing a.num and b.num. What will happen? When these two things are gone, actually the 300 object is gone, no longer required, and this link, the a1 to 200, is also gone. What remains is this 200 and 100, the a and b original variables, which is now pointing to say old object. Sorry, so this should be 2 and this is 1. And that is why when we print the values of a1 num and a.num and b.num, we are getting 2 and 1. Okay, I hope this is clear. Okay, so this is parameter pass when it's a complex type, when we pass the instance of a custom class, whatever class. Then also the parameter is being passed by value, but that value is actually the reference to that object in the heap. And still, the what is passed to the new method is the value in the stack, not the reference to the, but in this case, the value happens to be the reference of the heap. Okay. But technically what we can say is still the parameter is passed by value, because you see the parameter, what the value was passed is 100, 200, not the actual reference. Now you will ask like, okay, difference क्या है यहाँ पर में, ये पास बाय वैल्यू कैसे हुआ है, पास बाय रेफरेंस में क्या डिफरेंस है? So for this particular case, um, because I'm assuming that you have some knowledge about the C or C++ mechanism, like how the C or C++ supports this parameter pass by value, by reference, by pointer, right? So because Java has no meaning or no notion of parameter pass by reference, we always say that Java always supports parameter pass by value only. But if you really want to know what is by reference and what is by pointer, have a look at how is it supported in C++. Okay. So for now, that I hope that you understand, even for the references also, it's a memory location that is being passed to the parameter, which is actually the value in the stack, right? So parameter pass is still by value in case of custom class also. Now here is another scenario I want to ask. What happens in the string case? It's a simple class string pass, and then it also has a method modify, again static. It is receiving a string parameter test, and I'm giving it a new value, hello. The main method, I'm creating a variable test, initializing it value with value high, calling the modify. So high should go here in this test, and then I'm printing test. Now ready your answer. Think about your answer, whether it should print high or it should print hello. Because you see, the string is a class. It is not a primitive type. Okay. So as we saw earlier, when we change this, the variable of the custom class, it actually changes the original original variable also, like we saw a dot num. What happens in this case? String is a class. So now, should this be printing high, or because we changed here in this hello, should it be printing hello? I hope that you got the answer. Let's run this. It is printing high. It did not change here. Even though string is a class, and we just saw that even the classes, when we send the class, it's actually the location being sent, and then when we change the value, the original value in the heap should change. But that's not happening in this class. String is a class, right? It's not a primitive type. But whatever we just saw, the complex pass class, it is not applicable to the string. Why? Why string is still holding, in this particular case, string is still holding the original value, high only, and it did not change. It's supposed to be, right? It's a class, and I'm changing, it's a new object created, so it goes to heap, correct? And then when I'm sending the test, it's actually sending, or should be sending the memory location here. And in that case, I'm assigning a new value. So it should be actually changing the value of the original string. And I should get hello in this print method. Let's see what is happening inside. Okay. Okay. So everything is visible right away. In the main method, I created the test variable, which is of course the 100 location, memory location is 100, assuming, and it has the value high. When we call the method at line number 6, it goes here, and at line number 6, what is happening? Line number 6 is that I'm assigning a new value to the test variable in the modify method. The modified test parameter is now assigning hello, and why it has created a new object. I just wanted to change the original value, the original object that was passed, right? But it has created a new object. Why? Because strings are immutable. Once a string has been created, its value cannot be changed. And this is the primary reason why there is a concept called string pool came into existence. Why Java can support the pool of strings. Um, well, this can be another this can be topic for another session. So anyway, for now that you must know that strings are immutable once created, it cannot be changed. But why? I am just assigning a literal hello here. I'm not saying new object, new string hello, like I did in this case, new string hi. So why assigning a literal also created the object in heap? It's because internally JVM, JVM or JRE or JDK, which one? Huh? So think about it. What is the difference between the three? That may be another topic for another session, by the way. Okay. So in this case, Java actually creates in internally, it does like this: new string hello. Come on, hello. Okay. Yeah. So whenever we assign a literal string, internally it is converted into or changed into or executed as new string hello. And then because it's new keyword, object gets created in the heap, assigned the value hello, and the reference goes into the variable, which is test in this case. So the test variable in the modify method gets a reference of a new object. That's where the value hello goes, and it does not change the original value because anyway, strings are immutable. Once high is created, it's created, cannot be changed. And that's why when it comes back to the main method and we print the value of test, it remains high. I hope this is clear, and this is a difference from the last scenario that we saw. Even though we are sending an instance of a class, in this case string, it is still holding its original value, not changing. Okay, because string is immutable. Now, here is another question for you, and I'm not going to answer this. You may write in the comments wherever you see this and write your answer, or maybe ask the question in the Instagram, wherever you want to. Okay. This is wrapper class, wrapper pass, another class I have. Here is update object, basically the modify method only. It receives an integer. I just named it iTest, and then I'm changing the value 50 or assigning a new value 50. Then in the main method, I'm creating a new integer. It's a new integer with value 20. Calling the method, giving the test here. So integer goes. Integer is a class, by the way. You know that the int is primitive type. The wrapper integer is a class. Correct? So like whatever we had seen earlier, whenever we send an instance of a class, it points to the location in the heap, and the variable holds the actual memory location in stack, right? So in this case, what happens? The object gets created in the heap, it's the new 20, and the test goes into stack. And now, when we send this to this, initially it will receive 50, 20, and then I'm changing it to 50. And then when I print it, what will it print? 20 or 50? And remember that integer is a class, not a primitive, right? What will it print? 20 or 50? Think about your answer. And now I'm going to run this. Here I'm running. Cancel. What is happening? Okay, I didn't save it. When I run this, it is still printing 20. Shit. Integer is a class. I created a new object here, and I'm changing the value here. So it should be 50, because when we pass the parameter, the value in the stack actually gets passed, which is pointing to the memory location. So when the test goes here, it is pointing to the original object in the heap. And when I'm changing the value, it should actually change. Ideally, it should actually change the value in the heap, the object of the heap, created in the heap, right? And then when we come here, it should print 50, right? But it is printing 20. Why? That's for you to know. And give me the answer, whatever you think is the right answer, or please ask. By the way, that's the session for today. I hope that you know now that the Java only supports the parameter passed by value, whether it's a primitive value, whether it's primitive variables, of course, because they has no heap involved. Every value, the stack directly holds the value of the primitive variables. So whatever is in the stack gets passed to the new method, and that's how it works. Original value remain intact, and whatever the method changes in, whatever the thread changes in that new method has no effect on the original variable. Okay? So primitive, clear? When we pass an object of a class, the stack actually holds the variable, the stack variable actually holds a reference to the object created in the heap, the memory location. And it's the memory location as value being passed to the new method. And if the new method changes the value, the original object gets updated. And when it comes back, because the original object was updated, the update is reflected in the called method also, in the caller method also, right? That's what we saw. Whereas the parameter was passed by value only, not by reference. But in the case of string, we created the new object in the heap. The parameter was passed by value only in this case, of course. And we changed the value in the string, but it did not affect the original variable, the test. Why? Because string is a mutable, immutable object. String once created, high, cannot be changed. Right? I hope this part is clear. But the question for you now is, why in this particular case, integer is a class, and then it is still printing 20. It is not updating its value to 50. That's a question for you today. Okay? Give me your answer or ask me a question, maybe in Instagram or wherever you see this video. That's all for today, and thanks for joining. Bye-bye.